We are very fortunate to have tonight a fracking expert, one who sets a lot of the rules or has some influence on setting the rules for the state of California. He has an interesting background. He has a BA from the World College West from San Rafael, majored in political and social thought, PhD from UC Santa Cruz in political science and environmental policy. And he taught at UC Santa Cruz for several years. He has been a research social scientist and a principal research scientist at the Sierra Nevada Research Center. And online, if you go to the site, it lists all the papers. He's written dozens of papers associated with that position. But I noticed something that was common to a lot of them. They had words like collaborative conflict management, public participation and agency coordination, how we deal with community controversy. Sounds like they should put him in Washington, D.C. and have him tell Congress how to work. Because we certainly need controversy to be resolved and progress instead of stalemate. He's helped to establish the California Biodiversity Council, founder and director of Land Use and Natural Resources Programs at UC Davis, senior policy advisor to the Secretary of the U.S. Department of Agriculture, director of the Office of Environmental Markets at USDA, senior policy advisor to the chief of the U.S. Forest Service. Obviously, he's well qualified for the position he now holds as director of the Department of Conservation of the state of California. Mark has dedicated his professional life to integrating conservation, regulation, and development right where it matters the most, on the land, on the farm, and in the forest. His mission has been to inspire sustainable production and practices while maintaining a sensible balance between economic opportunities, environmental health, and human well-being. Mark's background serves the department well as he leads DOC's, Department of Conservation's 4 divisions, unified by the mission of managing California's working lands. Again, we're very lucky to have him with us. Would you please give Mark Nechodom a very warm welcome?
Thank you very much, Steve, and thank you for the invitation to come and speak. Lest you think that all I do is fracking, let me give you a little more background about what we do at the Department of Conservation. It's a fascinating department. It's actually relatively small, less than 500 souls work for the department, distributed all over the state. And we have the Division of Oil, Gas, and Geothermal Resources, and we'll talk about hydraulic fracturing tonight. That's regulated by that division. But we also have the Division of Land Resource Protection, which manages the Williamson Act, really the world's largest farmland conservation law, and is about to turn 50 years old, and is actually so successful that over half of the 31 million acres of arable farmland and ranch lands in the state of California are actually under Williamson Act contract. Many of the parcels and land around you here in Modesto are part of that. We also have a role in regulating mining in the state. We have the Office of Mine Reclamation, and we regulate earthquakes and tsunamis. You guys are quick. I've said that before and people look at me like, what? Very nice. Good. Got a live audience. The facts are that we actually house the state geologist and the California Geological Survey, the kind of sibling state agency with the U.S. Geological Survey. And our scientists and geologists at CGS, the California Geological Survey, have conducted world-class science on earthquakes, on strong motion. Much of what has been done here in California actually changes the building standards all over the world, including California. Every 3 years, we update local planning regulations, construction standards, etc. So it's a fascinating department. There are more propeller heads per square foot there than any other place in state government. I absolutely love it. And it is extremely challenging now that we are addressing hydraulic fracturing. So let me turn to this issue and not waste any time, because I'm actually quite interested in interacting with you and learning some of your questions and concerns. We are basically treating this era, this opening, stimulated by hydraulic fracturing, as an opportunity to not only regulate but to educate. I've spent decades working in conservation, land use, resource management, and I think we all know that the general public has very little idea where their water comes from. They don't know where their milk comes from, where their carrots come from, or where their gas comes from. Well, I'm addressing this issue and this evolution in oil and gas regulation policy as an opportunity to help the public really get a feel for what is it that we do in oil and gas. We as regulators do certain testing and observation. The industry is extremely innovative. It is very forward-looking, and it has an enormous amount of research in innovation and science and engineering that would kind of just blow you away if you spent a day in the oil patch with some of these people. One of the reasons, and I'm an old Jeffersonian in this sense, one of the reasons it's very important for us to treat this as a turning point in the public's demand for greater transparency, greater knowledge, is because the better informed you are, the easier our job gets. That is, when we're all dealing with the same set of facts, when we're dealing with the questions that matter, we can do a better job of regulating. The industry can do a better job of calculating where it needs to go and make investments. And you can feel like you actually have some kind of productive and meaningful role in shaping the rules. And that, to me, that's democracy. And I don't want to be Pollyanna-ish about this. Yes, it is very hard. Yes, it's been tough being kind of the piñata in chief for the fracking debate. But this is an opportunity to come and talk with you and to show you some of the basic things that are relevant for you to know about if you take a greater and greater interest in this issue of hydraulic fracturing. So, let's look at the big picture. Just some very basic information for you. Most people in California do not know that California is the third largest oil producer in the country and the fourth largest in combined oil and natural gas. Most people don't know that. It is a huge part of this country's production. And yet, for the most part, oil and gas production has kind of been out there. If you wander down west of I-5 and you end up in the thriving metropolis of Taft, you'll kind of notice a whole bunch of pump jacks out there, and you might think, that's kind of interesting. I wonder what that is. Well, this issue of hydraulic fracturing is all about you knowing and they knowing much more about how that got there and why it is that we regulate the way we do. Oil has been produced in California for over a century. The Division of Oil and Gas, currently the Division of Oil and Gas and Geothermal, was established in 1915 with a dual mandate. First, and most importantly, is the protection of public health and safety. But secondly is the protection of the resource. Why, you might wonder, is that a mandate for the department? Think of it this way. Raise of hands here. How many people have seen There Will Be Blood? Fair number of you. My bet is a few of you are going to go home and want to watch it after this talk tonight. You may remember early on in the film, they're basically hand digging these wells, and when they do hit oil, there's a lot of water involved. In fact, in California, most oil production is actually water production. There's a lot of aquifer water and old seawater in pockets about the same places that the oil is. The mandate for the division to also protect the resource is protecting the hydrocarbon zone from getting flooded with water. So you drill a well down, you get to the hydrocarbon zone, and all of that water, if the well is not properly constructed, starts to flow with gravity down in and essentially pollute the oil. So that dual mandate, very early in 1915, guided much of our regulations and helped us develop very stringent standards in well construction. How the well is built and how it is managed and operated is the core of what we do in that division. In the state of California, we have over 217,000 recorded wells. There are a few out there that we can't find that were probably drilled in 1896, but almost all of them we have, and they have a specific number, and they have a record, and we keep all of those records, and increasingly those records are electronic. Out of that, currently 94,000 are in operation, in quotes, because some of them are idle because it's not economical to actually operate them. We have over 16,000 injection wells, and I'll talk about that just a little bit as we go along here. But we are looking at over 77,000 producing wells. These are wells that are built to produce, pull up out of the ground, use a pump jack or whatever method to pull oil and gas out of the ground. Our challenge in this new era of regulation of hydraulic fracturing, and now with the passage of Senate Bill 4, which I'll just refer to as SB 4, Senator Pavley, Adam Gray, one of the legislators here in the Central Valley, and a few others. It was passed, the governor signed it, and it now is the most stringent, or it will be the most stringent regulation of oil and gas in the country, adding already to California's regulations, which are already some of the most stringent in the country. Those injection wells are there to both dispose of liquids that are and water that are part of the production process, but they also perform a very important function. In California, most oil production is also enhanced by injecting water down into the geological formation and pressuring that formation so that oil flows to the production wells. It's our underground injection control program, and it is a major part of production in California. So that's why we have nearly 17,000 injection wells, and I'll talk a little bit more about that. They're quite different from wells that are hydraulically fractured, but some people get those confused. Hydraulic fracturing, yes, is injection, but these injection wells I'm talking about are actually pumping 24/7 for a very long time over the life of the well, and actually moving product to the production wells, versus hydraulic fracturing, which is an operation that might go on for 1, 2, or maybe 3 days, a very short time. We produce in California nearly 200 million barrels of oil. That was last year's data. And about 230 billion cubic feet of gas just in the state of California. Daily consumption in the United States is about 14 million barrels of oil. So we use a lot of oil. California is the third largest consumer of oil in the world. There's China, India, the rest of the United States, and California. That's how much product we use in this state. So it's very difficult to imagine how we would rapidly reduce our use of hydrocarbons or use of oil without serious disruptions to the economy, your well-being, and quality of life. However, let me emphasize something. One of my favorite little ironies about my fun career is I've just come from Washington, D.C., working at USDA, where I was one of the primary people responsible for developing the methodologies for mitigation of greenhouse gases. We may not all agree on this, but the policy is that greenhouse gases matter, that climate change is real, and reducing the amount of carbon in the atmosphere is absolutely critical to our future. And then I end up in California as Governor Brown's appointee to regulate hydrocarbons. And so I'm treating this as a kind of a great big Zen koan that I meditate on, and figure out how are we going to get this done. And I think this is really all of our Zen koans, which is how are we going to get this done? How are we on this planet going to transition from a heavy dependence on hydrocarbons in whatever form to something else that is less environmentally damaging? That's all of our challenge. That's a challenge of multiple generations. It's a challenge not just of the century, but of the millennium. So I haven't lost sight of that challenge. I just simply happen to be now in charge of regulating oil and gas, but I do so in that larger frame, and I take it very, very seriously. Let me talk a little bit about, let's see, which one of these buttons? Here we go. The Monterey Shale. How many people here have heard of the Monterey Shale? Okay, thank you for the show of hands. So, I'm going to show you where the Monterey Shale is. This is the Monterey Shale. Oops. This is the Monterey Shale. No, this is the Monterey Shale. No, wait. This is the Monterey Shale. Really, this is the Monterey Shale. The point is simply that the mythical Monterey Shale is a formation of deep, what we call source rock. It is the rock that has, and it's a very dense rock, it's a metamorphic rock, that has a lot of hydrocarbons bound into it, but if you were to take Steve's hammer here and whack on it, you wouldn't have very good luck finding the oil. It's really bound in there. Now, geologically, what happens is all of this oil that we've been producing in California, and I'll show a diagram in just a minute, has essentially seeped up from that source rock and been captured in geological formations above that and has formed these reservoirs and pools of oil and gas over time. The big challenge of exploring and producing from the Monterey Shale is, can we go to the source? And the question is, what will unlock that source? Many of you know that in the press, there's been almost this assumed binding relationship between hydraulic fracturing and producing from the Monterey Shale. From the oil industry perspective, that's not true, and you'd think they'd be the first to know. And in fact, many of the exploratory wells that have gone deep enough to tap into the Monterey Shale have not been very productive, even with hydraulic fracturing. So the question is, even though this is a massive amount of oil, 15.5 billion barrels, 2/3 of the shale oil reserves in the United States, nobody has yet figured out how to crack that code. So as we spend time whipping through the various versions of the Monterey Shale, keep in mind that the oil companies themselves are investing an enormous amount to try to figure out how do we tap this resource. Should they? Should they not? I say that is a public policy question, even a philosophical debate that you all need to have. And my preference is that you have that as informed as you can possibly be. Now, a further issue about the Monterey Shale. This is kind of an idealized layer cake geology of back east, let's say, where you have, I know this works. There we go. Where you have a layer of shale, and you've heard, I think, of directional drilling or horizontal drilling. The big innovation is many of these horizontal drills can go out literally for thousands of meters, if the geology behaves. Back east in the Marcellus Shale, for example, that's basically a layer cake kind of order there. And you can frack in various stages. I'll have another diagram in just a minute. And you can actually be very productive with one well bore or one string. And then there's California. As usual, let me get these buttons straight. As usual, this is California. The Monterey Shale and our geology is all wadded up and twisted. Pacific plate is riding up, the continental plate is riding up over the Pacific plate. We have all of this tectonic action happening. So it's not at all clear what the technique should be for drilling a well bore down into the target zone. So in California, you're less likely to see horizontal drilling, very long multi-stage frac jobs, and therefore the use of a lot of water. So I want you to be aware that the challenge of actually tapping the hydrocarbon resource requires an enormous amount of research and seismic studies, and the extended drilling and extended reach, or directional drilling, is getting good enough that in many places, I am told by the industry, that they can hit a target zone the size of a swimming pool about 5 miles away. So it's pretty good stuff. Not perfect, but it's pretty sophisticated. Let me talk for a minute about SB 4, Senate Bill 4. There's some key elements to this, and this is a total game changer for our department, for the division, for the legislature, and for the state of California. You've probably heard in the press that California doesn't regulate fracking. In fact, we have not a clue what's going on. I contest that. In fact, we regulate fracking. We regulate the construction and the operation of any oil well. And if you're going to hydraulically fracture it, we have regulations for how it is that the construction and operation of that well has to ensure that liquids and fluids don't go where they're not supposed to go. But we have not had an explicit regulation targeted to precisely hydraulic fracturing. So now with the current attention on this, much more desire for transparency, we will have regulations precisely aimed not only to hydraulic fracturing, but to well stimulation in general. So, SB 4 requires us to produce an environmental impact report statewide by July 2015. It's not very far away. An independent scientific study will be completed by January 2015. And we're talking about 15, 18 months from now. So I don't know if many of you are familiar with the, how shall we put it, the majestic pace of government. But that's a fairly short timeline, and we've got to hustle. And we're actually putting a lot of new people in place in order to achieve these. We have multiple interagency agreements that we have to formalize with the State Water Board, the regional water boards, the Department of Toxic Substance Control, the Office of Environmental Health Hazard Assessment, the Air Resources Board. We've got a lot of work because all of this regulation stretches across various jurisdictions. And when I first got appointed here, I told my staff, nobody gets to say it's not my job. You do get to say, this is our jurisdiction, and if you're interested in who regulates the air stuff, we can help you find that person, but you don't say it's not my job. We're all public servants. So we've got a lot of work to do to make sure that we're tied in with the air and the water and the toxics people to make sure that our collective regulations make sense. A final regulation needs to be in place by January 2015. A rulemaking process in state or federal government is an enormously complicated affair no matter what you're doing, but now we're talking about well stimulation, hydraulic fracturing. A lot is going to go into this, and we're going to be hustling. And frankly, we will need your engagement. We're going to need you to know enough about this so that when we get to the public workshops and the public comments, we need you to come in and read this stuff, figure out what it means, and tell us what you think. Finally, in order to get there and still continue to work in the oil patch, we need to have an interim certification process that assures the public and everybody else that in fact we are regulating hydraulic fracturing and well stimulation in an orderly fashion. So nobody gets a pass until we have regulations. Now consider that we've been using hydraulic fracturing, the industry has, in this state for over 60 years. And not one report have I found in all of our records in which there is an upset from hydraulic fracturing that has actually had fluids going to an aquifer or any other damage. So the record is pretty thin on the facts of damage, but I'm taking the risk seriously, and it's my job to make sure that we assess risk and protect public health and safety properly. So with all these things going on, that division of oil, gas, and geothermal resources is going to grow from currently about 174 people, most of them engineers, to, who knows, well over 200. We're trying to figure this out right now. We're working with the legislature. We've got a lot of work ahead of us. It's very important out of that 77,000 production wells to figure out how many of those are actually subject to this new regulation. We have to be very precise here. So we have drafted a definition of well stimulation that enables us to figure out, of those 77,000, who's in, who's out. Is it 20,000? Is it 50,000? Is it 200? That's what we have to do for regulation. Now, let me pause for just a minute to dwell on this definition very carefully. In reality, it's not about well stimulation. I'll have a picture for you in a minute. It's not stimulating the well, it's stimulating the formation. It's stimulating and changing the flow of hydrocarbons in the geological formation itself. So when we use the term well stimulation, which has become the popular phrase, you really need to think in terms of it's not about the well, it's about the rock. It's about the hydrocarbons. So what we're trying to define here is any mechanical or chemical operation that's done through the oil well that is intended to change what we call the in situ permeability of the hydrocarbon-bearing formation. What that means is where oil is not moving toward a production well, you're trying to change the structure of the chemistry so the oil does move toward the production well. And that's the nature of the regulation. What it includes is not just hydraulic fracturing, which was what you came to hear about tonight, but also acid fracturing, the use of hydrofluoric or hydrochloric acid in order to reach a level of pressure that fractures the formation and creates cracks, but it doesn't leave behind proppants, and I won't get into the nerdy details quite now. And then acid matrix, in which acid is used in fairly large quantities to kind of soak out into the geological formation and to melt away some of the crystals and things that are in the way of flowing oil. So the intention, again, is to change the in situ permeability of the formation itself. Now, I apologize to those in the back. This may be very hard to see, but I wanted to show this diagram so that you understand how our regulations actually have been in place for a very long time, and what we're doing with this new regulation is essentially strengthening, adding some details and some reporting to, but ensuring that you get to see as much as we see as engineers and regulators who review these. First of all, everybody's concerned about the possibility of polluting aquifer water or groundwater. This is why in California's regulation, we require in every case what's called the surface casing, which goes from the surface down to the zone that is well below all protected water. Protected water legally is defined as any water source that is below 10,000 milligrams per liter of total dissolved solids. That's pretty briny. Pacific Ocean out there off the coast is about 32,000 TDS. There are other parts in the world where the ocean is 45,000 TDS. If it's 10,000 TDS or less, we're protecting it, we regulate it, no matter where it is. And then you see a layer of cement and another layer of steel, the intermediate casing. And that goes way down. Of course, this is not to scale. And then the actual production activities go into a third casing, and sometimes there are 4 casings. So the point here is for you to understand that there's rock, cement, steel, cement, steel, cement, steel before any of the production or hydraulic fracturing or any operation happens. That's pretty solid stuff. And it's very unusual for any of this stuff to break in such a way that stuff you're doing down here in the hydrocarbon zone at 3, 4, 10, 12, 14,000 feet down would somehow leak up into here, into the aquifer zone that can range from wherever the water table is, 20 feet to 200 to 800 feet. So there's a fair amount of separation and a lot of geology in between the hydrocarbon zone and the potential water sources that we're all concerned about. There's a lot of protection and a lot of requirements for testing and monitoring. So, given that we have this kind of construction requirement, I want to just make a distinction between back east, go back to my earlier diagram about horizontal drilling. These fractures are done in multiple stages along a long line that's horizontal. And then you have essentially a lot of surface activity, or more typically in California, you have multiple stages that are vertical, and you have a lot of surface activity. It took me, I'm a little thick-headed, but it took me several public workshops before I finally got what people were really concerned about. And it's not necessarily hydraulic fracturing as a technical technique, it's the land use impacts. It's all the trucks, it's the water, it's the air, it's the social disruption. That's what people are worried about the most. Now, I said we don't get to say it's not my job. My department does not have land use authority, but I think many of you in this audience knows that all land use decisions in California are 3 votes on Tuesday. That's how land use happens in California. It's the city council, board of supervisors, where things happen and what you have to do to mitigate them is a land use decision. And I would propose to you that if indeed we have a new oil rush or gold rush from the Monterey Shale, and all of a sudden we discover how to produce all of that oil, that the land use impacts are going to be significant, and it's up to you and me as citizens to be involved in the discussion about where you want this stuff to happen. How do you want it to happen? What kind of truck trips? When do they happen? Noise, etc. All of these things are important public policy choices that all of you will have a role in controlling. This is just another diagram of the kind of casing testing that we require. In our new regulations, we will require running the pressures up to 150% of the anticipated fracture pressure. So if you're going to fracture at 10,000 pounds per square inch, which is not unusual, it's a lot of pressure, we will require that the casing be tested to 15,000. So that's to ensure that the well is competent and able to take the kinds of pressures that are used in the fracture job. I'm going to go through 6 bullet points here very quickly to tell you what the regulations include. And some of these I think you'll want to be paying attention to as we unfold these. Hydraulic fracture, another stimulation process. This is the definition we were talking about so that we know which wells are actually involved. It's not all 77,000 of them, but it's some subset of them. There will be public disclosure. There's a 30-day requirement prior to hydraulic fracture operations to disclose to all neighbors within 1,500 feet of the wellhead and within 500 feet of wherever you are on the surface that's right above the fracture zone. So we're going to have some interesting challenges figuring out with the operators how to do the notification. But if you're in that area, you'll probably get some kind of notification by mail that says, ERA or Oxy is going to hydraulically fracture a well in your neighborhood. and this is how it's going to work. You can find more information on the department's website, etc., so you can remain fully informed. To enhance this, I've asked my IT division to develop, how many of you know about Zillow? Just curious. Anybody use Zillow here? Yeah, so you sign on with an account, you say, I'm curious about this neighborhood, or I want to watch this house, whatever. We want to create an account for you on the department's website that says, pick any point, a centroid, a circle, a geofence it, a polygon, whatever, and have the system email you every time there's a change in any of the permitting steps. So if we issue a rework permit, a plug and abandon, a hydraulic fracture permit, the system emails you. We should be in beta hopefully in the next few months, and I'm kind of excited about being able to do this. This is, again, part of our public transparency efforts. The other part of the transparency is the public disclosure of the fluids used in the stimulation process. Many people are very concerned that oil companies and service providers are injecting an unknown cocktail of chemicals down into the geological formation, down into the earth, and you don't get to know about it. That's going to change. My suspicion is the more you know about this, the more you will begin to say, I get what they're trying to do, and you'll ask the question, is the division or is the department watching this properly to assure me that none of this nasty chemical stuff gets into the aquifer or gets to places it should not be? And that's our job. Oops. Related to that is we will have requirements for the operator to report to us, where do the fluids go? We are moving increasingly in California to a complete closed system for fluids. So if you're injecting something into the well, comes back up, or whatever comes back up, it never sees the light of day or air. It goes into tanks, it goes into pipes, it goes into disposal areas. Increasingly, we are requiring that, so we're not allowing open sumps, pools of chemicals and that kinds of things that were very concerning to people back east, where open sumps were used for chemically laden, what we call flowback fluids. That won't be allowed in California. We also will have requirements for groundwater monitoring. This is where we'll be working very tightly with the water boards to develop the rules for how we do the groundwater monitoring. It may be testing your well. We have a provision in the regulations that will offer to every landowner or tenant an opportunity to have your well tested by an independent third party. You get the results. We're going to figure out the legality and the probably some complicated steps in that. But again, it's an opportunity for you to get actual information that's relevant to you and know that you are protected by the regulations. And finally, this is a whole suite of information that we'll be requiring for each stimulation treatment. So it's the location, it's the entire well path, a whole series of things that will be posted on our website to be available to you, so you can basically know as much as you care to know about how the industry works. Just for the sake of comparison, we put together a table to let you know how California is measuring up to other states. Now, I know there's always kind of a tendency for California exceptionalism, and I don't want to indulge that here. But in fact, along all of these requirements, whether it's cement evaluation, and what that means is running a test down the wellbore, down the steel casing, usually using electrical signal to ensure that there are no gaps or voids in the cementing around the casing. So ensuring that the entire casing system has integrity. A complete review of the geological formation all the way around the fracture zone. In the Pavley bill in SB4, they say, if you think you're going to get 100-foot fractures, we want you to go out to 500 feet and make sure that there are no faults or other well bores or things that could be a problem around that. And of course, we have ongoing monitoring that will be required after this. So I want to leave you with another kind of observation and comment. This is sort of factoid based fun things to know. I mentioned earlier that California's oil production is really water production. You have a really, really good well. If your well produces 95% water and 5% oil, that's actually a really good, what's called in the industry, water cut. Oil companies in California are really water production companies. That's old seawater, ranging from, it could be 3,000 TDS all the way to 30,000 TDS, very brackish, not usable. In the state of California, every year, we have 120 billion gallons, 3 billion barrels of water that circulates up from its original place in the geology and gets re-injected back down. 120 billion gallons is circulating up and down. It's a closed, for the most part, a closed system, but that's a lot of water. Now, people have been very worried about how much water hydraulic fracturing uses. We did a study of the reported hydraulic fracture jobs that were done since 2010, and we counted 270 acre-feet had been used. Now, compare that to 5.5 million acre-feet of water that transfers through the delta every year, that's surface water. So we're not talking about a lot of water. In fact, it's relatively little water. The average use of water for a hydraulic fracture job in California is 116,000 gallons. For those who have been very eager to have oil companies be singled out and reporting the source of their water and where it goes afterward, that's fine for public transparency. But one has to ask oneself as a public policy question, are we really going to ask Campbell's Soup, Harris Ranch, Paramount? Is everybody going to report? So there are some public policy and equity questions here. I'm not trying to protect the interests of the oil companies. I'm their regulator. I don't work for them. I missed out on the salary. But no, I'm a regulator. But I do have an obligation for fairness and equity and to base our regulations on science, facts, evidence, and not emotion. And I hope that you would hope that that's how I would be the regulator in charge of stuff to protect public health, your environment, etc. So I'm going to leave it there. Would love to hear some questions. Steve, I don't know how the format works here, but thank you very much for the invitation tonight.
Is the water drinking water, or is it brackish water that they use?
For hydraulic fracturing?
Yes.
Currently it's fresh water because of the complicated chemistry involved. However, I do know that a lot of research is being done to be able to use recycled, what's called produced water, which is that water I'm talking about coming up. It actually just costs more money to use fresh water. So it would be much more practical to use produced water.
The nuclear industry for years was assuring the public of the safety of nuclear power, and yet lots of problems have surfaced over time. And part of the pressure was on the regulators to conform to the industry. And sometimes it was deception, is what came out. And so you seem like an honest person, but others could be paid off by the industry or pressured in some way by the industry to make assurances about which there isn't really certainty, only probability or hope, perhaps. And so I'm concerned, given the close connection often between regulation and industry, that the regulators will not be doing their job as seriously and responsibly as they need to do.
A very, very good point. Thank you for that. The example you use is near and dear to my heart. My father was part of that first cadre of nuclear engineers in the 50s to carry forward nuclear power from the Cold War weapons into peaceful use of the atom. And when I had the capability to actually grow hair, I had a ponytail down to the middle of my back, and I was out protesting nuclear power because I didn't believe them either, and I didn't trust the regulators. That's a personal part of this, it's a personal part of this, but it has also built in me a deep public service ethic that says you damn well better tell the truth. Do not lie to citizens. Do not get too close to the industry you regulate, even though it is a very important tension, because we have to work and we have to trust the people we work with. And I will tell you that in my experience, whether it was my prior work in the timber industry or my current work with oil and gas or mining, 98% of the operators or the people out there are just fine. Most of your time is spent on the 2% of the deceptive or the cheaters. As a systemic issue, let me go to the heart of what I think you're saying, which is, I'm telling you that hydraulic fracturing is a safe activity and we want to regulate it properly. That's the core of my message, among other things. Can you believe me? And I have to work extra hard, not just me personally, Mark Nechodom, but my division, my department. We have to work extra hard to ensure that we are telling the truth, that you do trust us, and that you have a means of verifying. When we screw up, we have to say, we screwed up. When we get it wrong, we got to tell you, we got it wrong. So I don't know an ultimate remedy to that besides daily polygraph tests. But I'm willing to go to extremes to ensure that the regulators truly do the regulation as they're supposed to.
Dr. Nechodom, I'd like to ask about SB4 a little more specifically. I know your boss, Governor Brown, just signed it into law, a week ago or so. And the thing is, that bill as originally written was a lot stronger to begin with. And even though most environmental groups in California were for a statewide moratorium on fracking until we figure out all these problems, these potentially severe problems, some environmental groups in California were actually in favor of SB4 as it was originally written. But at the last minute, and you know this better than I do, I'm sure, at the last minute, there were a bunch of amendments to that bill that even the few environmental groups that supported it, they had to back out. And now they no longer support SB4. NRDC, Natural Resource Defense Council is one of them. There's a few others that were originally supporting the bill as written. They thought it was a step in the right direction. But at the last minute, big oil and gas lobbying organizations like the Western States Petroleum Association sort of gutted the bill. Big oil and gas lobbies have big power in Sacramento. They're the biggest lobbyists up there. You know, at the national level, it's pretty much one department that does the heavy lifting for oil and gas. But we're lucky here. I guess in California, we're kind of bipartisan in that way. Both parties do heavy lifting for the oil and gas companies. And that's why, despite your presentation tonight, SB4, they say it was kind of gutted. That the notice to neighbors who are going to be fracked nearby, it's only 30 days. You're giving oil companies 2 years to come up with an environmental impact report, but neighbors next to fracking get 30 days to try to do something about it. That the groundwater monitoring is going to be done by the oil companies themselves. Okay, then go. Two questions. One is, how did SB4 get reduced down to, it certainly was changed, and it certainly was made more in favor of oil and gas companies at the end. How did that process happen? And tell us about some of those changes from the original bill, if you know them. Thank you.
Respectfully, that's a setup. And I really can't tell political stories out of school. I was there. I was very much involved in it. We had a number of amendments. There are some interpretations of certain parts of the as-enrolled SB4 that some thought gave extraordinary power to the division, which actually is not true. And I can talk about the very specific stuff that came out in the press about the supervisor being able to deem things already compliant with CEQA. We can talk about that in greater detail if you wish. But I would rather pass on the politics of whether it was weakened and whether big oil was somehow nefarious in its activities. My job is to be the regulator and take what I get.